All right. So we're going to be solving this equation, this 3 by 3 system of linear equations using row reduction. So in order to use row reduction, the first thing we need to do is put it in its augmented matrix. We need to write the augmented matrix for this. And to write the augmented matrix, you take the coefficients of the x, y, and z. So for the first row, it is 8, 3, minus 12, and then equal to that part go in the augment section 2, then this is now minus 5, minus 2, 8. In the augment part now we put 3, and then we have 10, 4, minus 15, and in the augment part we put 1. Now what we're required to do is use row 1 to get zeros in row 2 and row 3 in the leading entry. So we need to get zeros in row 1 and row 2. So how are we going to get 0 in row 2 and row 3 using row 1? So our new row 2 is going to be equal to, we can multiply row 1 times 5. So we can say 5 row 1 plus 8 times row 2. That will give us 0. 5 row 1 plus 8 times row 2. Then our row 3 is going to be equal to, this is 8. This is going to be 8 times row 3. 8 times row 3 plus, not plus, minus 10 times row 1. That should give us 0 in row 3. Let's check it out. So all you need to do now straight away is write back your row 1. Your row 1 is 8, 3, minus 12, and 2. And then now your row 2 is going to become 5 row 1. 5 times 8 is 40. 40 plus 8 times minus 5 is 40 minus 40. That gives us 0. Then we'll go 5 times 3. 5 times 3 is 15. 15 plus 8 times minus 2 is 15 minus 16, which is minus 1. Then we go 5 times minus 12 is 5 times minus 12 plus 8 times, it's 5 times minus 12 plus 8 times 8, and that is 4. This is going to be 4. And then we're going to have 5 times 2, 5 times 2 plus 8 times 3, and that is 34. This is 34. Nice. That's what you get. Now, for row 3, now it's going to be 8 row 3 minus 10 row 1. So 8 row 3, 8 row 3, where is row 3? 8 of this, 8 times 10 is 80, minus 10 of this. That's going to give us 0. Then we have 8 of this, 8 times 4 is 32, minus 10 of this, 32 minus 30 is 2. Then 8 of this, 8 times 15 is minus 90, minus 10 of that up there. So 8 times minus 15, 8 times minus 15, minus 10 times minus 12. Okay, I'm getting 0. And then we have 8 of this, 8 of this, 8 of this now. We have 8 of this. 8 times 1 is 8, minus 10 of this, that's negative 2. Now in this case, we're pretty much done, right? We're pretty much done. All right. because usually we want to obtain a 0 right here, but we don't have to in this case. We don't have to. Why we don't have to? Because look at it. We don't have to because what this is saying is, in this case, this is telling us that 0x plus 2y plus 0z is equal to -2. So what that is really saying is 2y is equal to -2. And so what that means is y is equal to -1. This is what that tells us, y is -1. Yeah, man. And if y is -1, look at the second part now. So we did use that from this portion. We got this equation from that. Now, look at right here now. From right here, what it is telling us is that we have 0x minus y plus 4z equal 34. So all you have to do now is put in y as -1. -1 is 1. So you get 1. So you get 1 plus 4z is equal to 34. And now, just want to make sure we did everything right, because this is going to give us some fraction. So let's just check back our algorithm, make sure additions were correct. All right, it's always good to do that. Just going to check back because I'm getting some decimal. So again, we have 5 row 1 plus 8 row 2. All right, 5 row 1 plus 8 row 2, 0. 5 times this is 15 minus 5 times 3 plus 8 times -2, that's -1 is good. 5 times -12 plus 8 times 8, that's 4, that's good. 5 times 2 plus 8 times 3, 34, this is good. Check the last row again. 8 times 10 minus 10 times 8, 0 is good. 8 times 4 minus 10, 8 times 4 minus 10 times 3, that's 2, this 2 is good. Then finally down here, it's 8 times -15 plus minus 10 times -12, 8 times -15 minus 10 times -12. 0 is good. Then finally goes 8 times 1 minus 10 times 2. Okay, this should have been -12. I made an error right here. All right, 8 of this, 8 minus 10 times 2. See here, 8 times 1 minus 10 times 2. This is giving me -12, so that's my error. This is my error. This is -12. All right, that is -12. So I can change this to -12. I can change this to -6. So y is -6. Since y is -6 now, we're good. Because now we can then say our second equation is -y plus 4z equal to 34. Then we can substitute y as -6. So that will become 6 plus 4z is equal to 34. And so 4z will be equal to 28. And so z equals 7. If z equals 7 and y equals 6, we can go to the first equation right here and then say 8x plus 3y minus 12z equal 2. But we know 8x plus 3y is -6. And then now we have -12 times z and z is, where is z? Z is 7, and this is equal to 2. So we transpose for x to get 8x is equal to, so we have 3 times minus 6 minus 12 times 7, that's minus 102. So we have 8x minus 102 equal 2. Bring that over to get 8x equal 104. We divide through by 8, and so 104 divided by 8 is 13. Nice. So the final answer we're getting is, we can conclude, so we can write x equal 13, comma, y equal minus 6, comma, z equal 7. That's what we're getting. This is our solution for this system. Now let's verify our proof is, as you can see, try x as 13 in, and y as minus 6, and z as 7 in the second and the third equation. So let's test in equation 3. Testing in equation 3. To test it in equation 3, what we're going to get is 10 times 13 plus 4 times minus 6 minus 15 times z. Z is 7. And what we get, that look like 130 minus 24 minus 105, and they still work out to be 1. So yes, the equation is true. Yes, it satisfies equation 3. Yeah, man. So we know we're good. And you could also test it in 2. So this is indeed the solution. X equal 13, y equal minus 6, and z equals 7. Soft.